Okay, hello everyone. Hopefully you can hear me all right. Welcome to our virtual planetarium show for tonight. Let me go ahead and introduce myself. My name is Aidan Gibbs. I'm a graduate student in the Department of Astronomy at UCLA. I will be your volunteer presenter for tonight's show. Tonight's show is going to be themed towards the big astronomical event that's happening tonight and has been happening for a while and will happen for a few more days, which is, of course, the Geminids Meteor shower. So a lot of what I'll be doing tonight is talking about the science behind the Geminids and also viewing tips for the Geminids. There won't be any live views of the Geminid meteors tonight, so do be aware of that. If you're looking for that, there are other streams available for live views. Another element of what I'm going to be talking about tonight is just amateur astronomy and astronomy as a hobby. And the reason I'm going to talk about that is because, the Geminids are a great event to go out for and look at the night sky, but there's tons of other, amazing night sky objects that you can see basically at any time of year. And so I want to talk about those as well. So it's great to see people tuning in from basically all over the US. Is anyone tuning in internationally? I haven't seen any yet. So let's see. Let's get started. So as I was saying, this sort of show is inspired by actually two excellent sky events in December. One is the Geminids Meteor shower, which is happening tonight. We're actually a little bit past the peak of the Geminids Meteor shower. Technically, the peak was last night, but that's okay. There's still plenty of meteors that you can see tonight as well. So this is an image on the left of some Geminids from, I think this picture was taken in Slovakia. Actually, there's some other great sky events happening in December. There's actually one event today that I'm not really going to talk about too much, but there was actually a total solar eclipse today in South America. There wasn't any part of the eclipse, unfortunately, visible from the northern hemisphere, but I'm wondering if anyone maybe was in South America to see that. But unfortunately, we weren't able to see that in the northern hemisphere. But another really great sort of astronomical event that's coming up is the so-called Great Conjunction between Jupiter and Saturn, which is going to happen on the 21st. Very quickly, basically, this means that Jupiter and Saturn are going to be incredibly close to each other in the night sky, and so it'll be a great time to look at both Jupiter and Saturn. So these are the events that I'm going to be talking about first tonight. After that, I am going to go into just amateur astronomy in general. What can you see in the night sky just on a regular basis? Maybe while you're out waiting to see meteors, patiently waiting for some shooting stars to go overhead. These are basically some other things you can look at in the night sky. All right, I do want to start by just talking about what actually is a planetarium, just so everyone's on the same page. So this is a picture of the physical UCLA planetarium. Unfortunately, we can't be there tonight. But normally, when you would go to a planetarium, we'd have this great projector in the very center of the planetarium, and this projector would basically project all of the stars in the night sky and show you. And what really is the point of a planetarium is to show you what the night sky will look like, basically from anywhere in the world and at any time of night. Now, of course, we're doing tonight's presentation virtually, so instead of having a projector to do this work, we'll actually have a piece of software. Some of you might know this software. It's called Stellarium. I'll go ahead and switch to it now. And so what Stellarium is it's a virtual planetarium software. It's a free software. You can actually download this yourself and explore the night sky yourself after this. There's also a web version of it. I think there's also a paid phone version of it. But yeah, so this is our Planetarium software, and what this is going to let us do is basically look at what the night sky will look. We'll be able to look at the night sky as it is from Los Angeles right now. So you might, looking at this, you'll notice that we have a nice snowy landscape. Obviously, this is not the landscape of Los Angeles, but I figured I would choose a snowy landscape for us since it is December. If we go ahead and look around, you'll notice that we can see some stars. You'll also notice that we have the cardinal directions all pointed out in red along the horizon. So the south is the direction that we were just looking. You can look to the west, to the north, the east. And right now, I actually have the night sky so that the light pollution is about the same as the light pollution that you would have here in Los Angeles. If you're from Los Angeles, you are probably very familiar with the fact that the night sky is very, very bright. So basically, light from our homes, cars, offices basically goes up into the sky and reflects back down at us. It hits particles in the atmosphere. It reflects back down at us, and so it makes the sky bright. And it washes out lots of faint astronomical features that we would otherwise be able to see in the night sky. So this is what it might look like if you were actually in Los Angeles. I went out 30 minutes ago. It looks, something like this. But of course, tonight we're interested in seeing a really dark night sky. So I'm going to actually turn down our light pollution. That's what I'm looking for. So I'm going to turn down our light pollution to basically show what the night sky would look like if you were in a very, very dark site. And I'll talk about some good places to go for a dark sky from Los Angeles in a little bit. Okay, so this is basically what I'll be using to show you the night sky. I'm going to go back to my slides and going to talk more about the science of the Geminids meteor shower. And please, if you do have any questions during this presentation, you can feel free to type them into the chat, and I'll do my best to, hopefully notice them and answer them if possible. All right, so let me just go over basically the fast facts of the Geminids meteor shower, give you the basics of it. So the Geminids meteor shower is a seasonal meteor shower. It happens every single December, so if you don't end up getting out for it, tonight or tomorrow night, that's okay. It happens every year. It's fairly consistent. On an average year, this meteor shower will produce the most of actually any meteor shower. It usually produces about 50 to 150 meteors, that is shooting stars, per hour. So you should see about 2 shooting stars per minute. This does assume that you are in a dark location, of course, with clear skies. So, if you're in a bright city, you're probably not going to see quite as many as that. So this year, the peak of the Geminids was actually this morning. So it was the morning of December 14th. So we're just a little bit past the peak now. But that's okay. Like I said, meteor showers aren't single night events. They basically increase and decrease over about a week or two. So there's still plenty of meteors to see tonight. And I should say, so this meteor shower produces 50 to 150 meteors per hour. On a night when there is not a meteor shower, you usually see something like 2 to 10 shooting stars per hour. So this is a significant increase from just your average night. You might be wondering why it is called the Geminids. And the reason why it's called the Geminids is all meteor showers are named off of where they appear to radiate from in the night sky. And so for the Geminids, that point is in the constellation Gemini. So all meteor showers are named like this. The Perseids, which we had a show about in August, came from the constellation Perseus. The Geminids comes from the constellation Gemini. So if you take a picture of all of the sort of meteors that occur over one night and you stack them up all into one photo, you'll get what this really nice photo on the left from a great astrophotographer. So this is all the meteors, I mean not all of them, but a good amount of meteors from one night of the Geminids, and you'll notice that they sort of all seem to kind of radiate from this one point, which again is in the constellation Gemini. I'm going to talk about how to find the constellation Gemini in just a second, but it's very close to the constellation Orion, which is of course probably one of the most recognizable constellations in the night sky. So I'm going to get into exactly why these meteor showers happen in just a second. So that's a good question. I'll also talk about fireballs in just a second. Let's see. So I'll actually go back to Stellarium for a second to basically show you where the Geminids are coming from. The screen always goes black for just a second, then it should appear. Alright, so we're looking towards the south. Again, this is the sky from Los Angeles as it is actually right now. What I want for us to do is to look towards the east. And towards the east, we will notice the constellation Orion that I just mentioned, which is just sort of peeking over the horizon. I'll go ahead and turn on some constellation lines so you can see Orion. Orion is the Great Hunter. It's basically supposed to look like a hunter who's carrying a club and arrow. So the easiest way to find Orion is his belt, which is 3 stars that are very closely in a line. And then there's sort of 4 bright stars that kind of form a rectangle around the belt, the brightest of which is Betelgeuse. I call it Betelgeuse. Some people pronounce it in a different way. So from Orion, to find Gemini, you'll basically just look to a little bit more towards the east or northeast tonight, a little bit towards the left. I'm going to speed through time a little bit so that Gemini rises. So now we're looking at what the sky will look like at 8:50 tonight from Los Angeles. Here's Gemini. Gemini is the Twins constellation. The most prominent stars are Castor and Pollux, which I will talk about later. And I can turn on the meteor shower radiant thing, and it'll show us where the Geminids is coming from. So the Geminids is coming basically right near the star Castor. But basically, if you look towards Orion, you'll be looking in basically the right area. Okay, and of course, these meteors aren't actually coming from this constellation. This is just where they appear to be coming from. So you might wonder why they kind of find they kind of come in this shower shape, and I kind of like to think about it like when in Star Wars when they jump to hyperspeed, and you see all of the stars around them that were stationary, and they kind of fly by, and you see this one point in the middle that all of them are coming from. That's basically what's kind of happening with a meteor shower. The Earth is traveling through basically some debris in space, some meteoroids, and basically the radiant is more or less where Earth is traveling through that meteoroid field. So Some of you might be wondering, and maybe have asked a few questions that are kind of related to a typical meteor. So what is like your average meteor actually like? What is it that is coming through the atmosphere and makes a shooting star? You might be surprised to learn that meteors are actually generally very, very small. So most of the ones that will sort of make a decently bright meteor, they're only the size of basically a grain of sand or even just like a small pebble. So they're not very large at all. And what you're seeing is actually pretty far away from you. So they first start to become visible at about 75 miles above the Earth. And virtually all of them will just be disintegrated in the atmosphere. So almost all of them will not even reach 25 miles altitude above the ground before they've completely basically evaporated away. Now, the reason that something so small can be so bright is because these meteoroids, they enter the atmosphere anywhere between 25,000 to 160,000 miles an hour. So very, very fast. In fact, I think the Geminids on average clock in about 80,000 miles an hour. So if you were traveling that fast on Earth, you could get between LA and New York in just under 2 minutes. So it's very, very fast. And you can imagine that when you hit the atmosphere traveling that speed, basically it causes a ton of friction. And so these small pebbles, they heat up to very high temperatures, over 1,000 Fahrenheit, and very quickly because of that, they'll generally disintegrate. And the trail that you'll see will look something like this. So this is just a short GIF of a typical shooting star. It usually has sort of kind of a bright head, and then it has this long tail. And of course, what we're seeing is basically a very, very hot, piece of debris coming in, and it actually ionizes the atmosphere behind it. That is, it breaks electrons off of the atoms in the atmosphere behind it, and so it actually does leave a visible trail behind it. Sometimes these trails can last actually a few minutes. So this is a typical meteor. One of you asked about fireballs. Fireballs are basically just exceptionally large meteors. So I said, a typical meteor is maybe a size of a grain of sand. A fireball might be a bit larger than that. Maybe something like a racquetball or maybe a tennis ball size. When it gets to be that big, it'll be very bright. Sometimes they're even said to make like a sizzling noise. When they get that big, you generally see them in the news. They are pretty rare, but of course they are more common to happen during a meteor shower. So, let's see. I'm gonna look at the questions for just a second. So let me talk about the actual cause of meteor showers. Why do they happen every year? Well, the source of the Geminids meteor shower is actually a little bit unusual. The source is an asteroid. The reason that this is unusual is that the source of most meteor showers are comets. And how these objects basically cause meteor showers is that comets, they basically eject lots of debris as they approach the sun. So you probably know that comets have a long tail, and this tail is partially basically debris that is being sort of melted off the comet as it approaches the sun. And then it's that debris that becomes the meteoroids that create the meteor shower. And so the meteor shower happens when Earth passes through that sort of debris field. So it's a little bit unusual that the Geminids is coming from an asteroid. The actual asteroid source is known as 3200 Phaethon. This is a radar image of the asteroid on the far right. It's about a little more than 3 miles in diameter, 6 kilometers in metric units. Yeah, and so this is actually a radar picture of the asteroid back when it had a close pass with Earth back in 2017. Now, unfortunately, I'm mentioning that this was taken with Arecibo Observatory. You may have heard in the news that unfortunately Arecibo Observatory recently collapsed, which is a huge loss to astronomy, not just to the staff that worked there, but a huge loss to astronomy. Unfortunately, it was unrepairable with recent damage, and then on the 1st of December, it actually collapsed, and which is really unfortunate because that observatory is basically the only observatory that can create radar images of solar system objects like this. But yeah, basically the Geminids meteor shower is being created by debris from this asteroid. This middle picture, by the way, is a picture of the asteroid flying by. It's this just sort of inconspicuous moving point compared to all the background stars. So what I'm going to do now is actually pull over a sort of visualization of the meteor shower as seen from space. So what you're seeing now is basically a 3D visualization of our solar system. And so I'll spend just a second to get you oriented. So in the center we have our sun, and then these different colored orbits are the orbits of different planets. In purple is the orbit of Mercury, and there's a small purple dot where the planet Mercury currently is. Orange is Venus, and then Earth is in this blue color here. Now in white is the orbit of this asteroid that I'm talking about. And all of these white dots are basically pieces of debris that get thrown off of the asteroid as it orbits around. And so the current time on this 3D simulation is December 5th, so it was just a few days ago, basically a week ago. You can see that the Earth is just about to basically enter this stream of debris that is created by the asteroid. So this is why the Geminids happen, is basically we pass through this debris field. Now, you might be wondering, why does this asteroid create this debris, whereas other asteroids don't? And actually, this asteroid is very unique in that it is creating this debris field. Well, this is still actually a bit of active research. Some astronomers think that this asteroid may actually be the remnants of a dead comet, and the reason for that is because it kind of has an orbit like a comet. And so by that I mean that it has an orbit that is very eccentric, it goes out past Mars, and then it dips really, really close to the sun. So you'll notice that the asteroid at its closest approach to the sun actually gets much closer than Mercury, and so it gets very, very hot, and so it's thought that because it gets so hot, this actually helps to basically throw this debris off and create the Geminids meteor shower. So asteroids, they can get basically as close to the sun as they want to, within a few times the radius of the sun. As long as they don't get within that, they will survive. Although comets, usually if they get that close, it's very hot there, so they can melt very easily. Okay, so this is just kind of a visualization of what's actually happening with the Geminids. All right, so again, I'm gonna just kind of look at the chat for some questions. So, Stephen asked about the safety of astronauts aboard the ISS during a meteor shower. That's a very good question. There is some extra risk to basically all satellites during a meteor shower because there is extra debris coming in. And I think most of the debris is still small enough that I think satellites and the ISS can survive small impacts with it. But for satellites in general, what basically aerospace people who control these satellites will do during a meteor shower is they usually try to position their satellite or orient it in such a way to minimize the risk. So maybe they know which direction the meteors are generally coming from, and so they can orient their satellite so that it has the lowest profile in that direction, or maybe a part of the satellite is stronger, and so they can orient something that is less critical in the direction that the meteors might come from to minimize damage. But it is a risk. It's kind of surprising that it's not more of a risk, but it is a risk. That's a great question. So, have I ever seen a meteor shower, and how much can meteor showers weigh? Certainly, I've seen meteor showers. They're really awesome to see if you can spend just many hours outside looking for them. It's awesome. As I'm saying, they're usually these are very, very small, so they probably only weigh a few micrograms. You probably wouldn't even feel them if you were to hold them. How bright can meteors be? That really depends. So most of them are very small. There's actually a significant amount of meteors that are so dim that you can't even see them. Every once in a while, you'll get a fireball that can be as bright as almost like the full moon, but that's very rare. And usually those make the news when that happens. Would we hear a sonic boom if a hypersonic meteor enters the atmosphere? So when you hear a sound, sometimes people report hearing sounds from shooting stars. You won't be hearing the sonic boom, and that's because, of course, these meteors are coming in at a very high altitude. They're usually, like a few tens of miles away from you, and it takes time for the sound to travel to you. So you won't hear the sonic boom at least for maybe a minute or two. But something about meteors that not a lot of people know is that they can actually produce radio signals. So when they streak through the atmosphere, they actually do produce some radiation, and that can actually cause some. It's thought that can cause some vibrations in sort of surrounding materials, and that is the sound that you will hear. Okay, so I think I know there's a few more questions, but I think that's enough for now. I'll try to answer a few more later. So now let me just give you some kind of advice from viewing the Geminids. So first one is just very simple. This is a meteor shower in December, so the most important thing is that you bundle up warm. And of course, if you want to stay outside and actually see meteors, if you're not warm, if you're cold, then you're going to go back inside very quickly. So wear as many jackets as you need to so that you can stay out for maybe an hour, because you do have to be patient with meteor showers. The other suggestion is to find a dark sky. This is particularly for viewers from LA. So if you're trying to view the Geminids from Los Angeles, Los Angeles is so bright that you're probably only going to see maybe a few the entire night. So you really need to get away from the city lights. The darkest place you can find is best. The Geminids is great because you don't need a telescope or binoculars to see it. All you need to do is you just need to look sort of vaguely in the direction of Gemini, which rises in the east, to see it. And the other tip is to observe early in the morning if possible. So the reason for this, if we go back to Stellarium, The reason why I'm telling you to observe early in the morning is because Gemini, where the meteors are coming from, doesn't actually really get very high in the sky until late at night. So now I've advanced time, and now we're at about 2 a.m., and the constellation Gemini is about right overhead. So that is when the best time to watch the Geminids will be. Okay, and this Solarium actually does simulate the Geminids, so I just saw a simulated meteor. It actually simulates the rate. So maybe as we continue to use Solarium, we'll see some simulated meteors, but you do have to also be patient even with the software. So I said that you should find a dark location to view the Geminids. For those of you from LA, that's not so easy. So I've listed a few locations that you might consider. So this is a map of light pollution. White is very bright, and then dark gray is very dark. So basically anywhere in the inner city of Los Angeles is not going to be a good place to look at this. The closest locations to be would maybe be Malibu, up to the Malibu Mountains, or San Gabriel Mountains. If you want to travel further afield, there's lots of different places you can go. The best place to travel to from LA that is pretty dark, it would be Joshua Tree. So that's probably the most convenient dark site to go look at the Geminids. So someone asked a question, how advanced is our ability to predict the path of asteroids? That totally depends on their size and how often we observe them. So asteroids up to basically 10 meters, or about the size of a house, asteroids like that regularly go undetected. So for example, the asteroid that hit Chelyabinsk, think back in 2013. That was like a house-sized asteroid and was completely undetected before it hit. Larger ones that are a danger to Earth are generally well observed, but there is always the possibility that we miss some of them. But when you get down to really small things like the meteors that we're talking about, we totally don't have any sort of prediction system for that, so that's why shooting stars are completely random. You don't know when they're going to happen because we can't track those objects. Okay, so I'm going to wrap up here talking about the Geminids specifically, and now I'm going to talk about the other great event that's happening in a week, which is the conjunction of Jupiter and Saturn. So this is a pretty special astronomical event. So again, what the conjunction means is really just that Saturn and Jupiter are getting very, very close to each other in the night sky. So this is just a little picture showing how close they'll get to each other. They'll actually be so close that they will almost appear as one star together, and this will happen on December 21st. This is going to be this is the closest visible conjunction of Jupiter and Saturn since 1226, so almost 800 years. This is the closest they've appeared in the night sky. They actually did appear this close, I think, back in the 1600s, but it was almost, it was not visible to most of the Earth. So this is the most widely visible occurrence since 1226. Why is this event happening? Basically, it's just a purely visual alignment. So in reality, the planets Jupiter and Saturn aren't actually getting closer together at all. It's just that they're getting closer together in the sky. So if we look again at the orbits of our solar system, we see the inner solar system here with Earth, and then the orbits of Jupiter and Saturn, and it just so happens that basically Jupiter and Saturn both align with the Earth. And so this is what is causing the conjunction. So I'll go to Stellarium and actually show you what this conjunction is going to look like. Like I said, we can change time to basically any day we want. So right now, I'm going to go ahead and turn off the constellation lines and the labels. And actually, we are very late at night now, so I'm going to go back earlier to basically sunset. Okay, and so Jupiter and Saturn, if we look towards the southwest sky, basically just after sunset, in the direction that the sun set, you'll see Jupiter and Saturn together. And I can actually go ahead and flip through the days now. So this new window that I've just opened, it has the year, month, and day down here. So I'm going to flip through the days to the 21st. And what you're going to see is that Jupiter and Saturn are getting much closer together. And then on the 21st, they are at their closest. We can zoom in on it. And they are very close together within 1/10 of a degree. And so this is a great time to observe these two objects. D, I see that you've mentioned Mars. Yes, Mars is indeed also up. I'm going to show you Mars in just a little bit. So they are not getting closer every year. This is so you can see that they've changed their distance between each other by quite a bit in just a few days. And after this, if I kept going, they will now get farther apart. And then eventually they'll get out of season and drop below the horizon in January. So I'm going to go back now to our current day, which is the 14th, and I'll go back to our current time. And so they just disappeared. So at this point, they've already set, but tomorrow night, you'll probably, it would be a good time to see them. Yeah, the software is called Stellarium. It's a free software. Actually, I think there should be a link in the description of this video. It's free to download for Windows, Mac, and Linux. There's also a web version. All right. So, someone asked, what's the difference between asteroids and meteoroids? So, asteroids are basically just large objects in the solar system, large rocky objects in the solar system that orbit the sun. They're usually fairly small, maybe a few meters in size. Meteoroids generally refers to very, very small pieces of rock and dust that will enter the Earth's atmosphere. They're called a meteoroid before they hit Earth's atmosphere. They're called a meteor when they are going through the atmosphere, and then they're called a meteorite if they actually end up hitting the ground. Okay, so now this is going to basically conclude my talk about the Geminids and the conjunction specifically. And now I would just want to talk about, for the rest of the show, basically just amateur astronomy in general. So I think that the Geminids and the conjunction, they're great opportunities to go outside and look at the stars. But there's tons to see, and so basically I want to give you an idea of what else you can see when you go out to look at the meteor shower. And then also, maybe if you're interested in getting into amateur astronomy as a hobby, I just want to give you an idea of what you can see if you do it as a hobby. So I'll be talking about just a variety of astronomical objects. Some of them you'll need a telescope to see. A lot of them you won't need a telescope to see. Some of them will be better with a telescope, and so on. And a lot of times when we do these presentations, somebody asks what we recommend for telescopes, and so I figured at the end of this I'll finally sort of address that question. How close do I know how close Jupiter and Saturn were in 1226? I do not know. Very rarely Jupiter and Saturn can actually occult each other, but that is an extremely rare. So they'll actually occur be in the same place in the sky as each other. Jupiter will block Saturn, but that is a very, very rare occurrence, and I think it won't happen for several thousand years. Any scientific study that can be done during the Jupiter and Saturn conjunction? I'm not really, this event isn't too big for professional astronomers because again, it's just a visual alignment. Back in classical astronomy, an event like this would have been very important just for studying the solar system, because you can use it to basically time the positions of Jupiter and Saturn very accurately, and so you can, using clever geometry and stuff, you can learn a lot about the solar system like that. But I'm not really aware of any professional uses for the conjunction, although that's not to say that they don't exist. Okay, so the first object I want to talk about that's really great to see on an average night is the moon. I know we basically all take the moon for granted, but actually the moon is a great object for amateur astronomy. If you have a small telescope or binoculars, people are they're really surprised by actually how much detail you can see on the moon. So on the right here is a picture with an iPhone of the moon through a small telescope that I found online. And you can actually see lots of depth in the craters. And so it's a really good first amateur astronomy target. You may not realize this, but the moon is actually best to be observed during its first or third quarter rather than being at a full moon. So what I mean by this is that it's best to observe when the moon is half illuminated. And the reason for that is because it adds a lot of contrast to the surface of the moon, and it adds a lot of depth to the craters, and gives you much better perspective on the landscape. So tonight is not a good night to observe the moon, which is good because we want to observe the meteor shower and the moon would just get in the way. But during the conjunction, the moon will be at first quarter, and so that'll be a great time to look at the moon as well, which will be in the night sky. And the moon's at new moon right now, which is why we had a total solar eclipse today down in South America. Okay. Now someone mentioned Mars earlier. So I want to talk about the planets that are best to observe in amateur astronomy. So we've talked about Jupiter and Saturn already. These are two planets you can easily see with the naked eye. Mars is another very, very prominent planet tonight. I'm going to show you that with Stellarium in just a second. I want to give you some idea of how you can actually see some of the features of these planets. So you don't actually need very much to kind of get a good look at these planets. If you just have a small pair of binoculars, any pair of binoculars will do, at home, and you can stabilize them, then you can actually see the rings of Saturn potentially, and you can also see the Galilean moons of Jupiter. So these are real images of Jupiter and Saturn and Mars as taken through small telescopes. So this is to give you some idea what you might see. Usually the first time you actually see the rings of Saturn is a very memorable experience because you finally realize that it's actually there and it's not just something you've been told about since you were a kid, but it actually does exist and it actually does have rings. So it's very exciting, and these are awesome targets to look at. So let's go to Stellarium and check out where they are tonight. Okay, so right now we're at the current time. Looking south, I'm actually going to go back in time just to show you where Jupiter and Saturn were again. So we're going back towards sunset. So Jupiter and Saturn, they set at about 6:30 tonight together in the southwest sky. Now, Mars, which again was mentioned, is also very, very prominent. You can see Mars right now in the southeast sky. It's, I think, pretty much the brightest object you'll be able to see there, so you don't really need to use a constellation to find it. And you'll know it's Mars because it has this really deep, nice red color, which is of course reflecting of its surface. So of course we know Mars is red, and it actually will appear a deep red to the just to the unaided eye. Something I want to mention with planets is that people are often wondering, like, how can they tell if something is a planet or a star? Well, the first way is that planets generally do not twinkle the same way that stars do. So if you look up in the night sky, you usually see that stars are like twinkling around. And the reason for that is that stars are just points of light in the night sky, and when they go through the atmosphere distorts that light and basically causes them to twinkle. But planets like Mars, Jupiter, and Saturn, they have a actual physical size in the night sky. So for that reason, they generally tend to not be as susceptible to atmospheric distortion, and so they won't twinkle as much. So I'll get to bright stars in just a second, by the way. Yeah, so another way that you can help identify planets is by realizing that all of the planets in the night sky lie along something called the ecliptic. So you'll notice that, you know, Jupiter and Saturn are over here on the right, Mars is up here. You can actually draw an imaginary line across the sky, which is called the ecliptic, which is the plane of the solar system in the night sky. And so I'll go ahead and turn this on now. So this is the imaginary line, but it's not imaginary. This is actually the plane of the solar system in the night sky. If I can actually get rid of the ground with Stellarium. And when I get rid of the ground, if we follow along the ecliptic, you'll notice that the sun also lies along the ecliptic. The moon lies along the ecliptic. Mercury is very close to the sun, also lies along the ecliptic. Venus, which is also below the horizon now, is all along the ecliptic. So all of the planets lie along the ecliptic. I'll turn the ground back on. And from the northern hemisphere, the ecliptic is always in the southern sky. So if you're ever looking in the northern sky and you want to know if something's a planet, well, there's no planets in the northern sky. They're always along this ecliptic line. And the position of the sun along the ecliptic, which constellation it is in, determines the zodiac signs of each month. Okay, so now is a good point to probably mention some of the very prominent constellations of the winter sky. So now I'm going ahead and moving forward time. I'll move it to about 9:30 tonight. This is the sky from 9:30. I want to go back to the constellations we were looking at earlier, Orion, Gemini, and then I want to point out some new constellations as well. So if we look at Orion, I mentioned we can find Orion's belt. And then we had Gemini to the basically to the left of Orion. I'll turn on the lines to make it a little easier. I want to mention two other constellations in this area. One is the constellation Canis Major, which is one of Orion's hunting dogs. So the mythology of Orion, that he is a hunter. So he has a hunting dog. And actually within this constellation, you can find the brightest star in the night sky, which is Sirius. So Sirius, it's called the dog star because it's in the this it's the main star in the hunting dog here. It's it's the brightest star in the night sky. So a lot of people think like the North Star is the brightest sky. That's actually not true. It's Sirius, which shows up in winter. Betelgeuse is another super bright star, of course, in Orion. Now, the reason that this is actually a good point about why stars are bright. So Sirius is pretty bright because it's very, very close to us. Betelgeuse is bright because it's very, very big. So Betelgeuse is a red supergiant star. It's much farther away than Sirius, but it's much, much brighter than Sirius, and so that's why it's pretty bright as well. So that's one constellation I want to point out. Another constellation is also related to Orion, is Taurus the Bull, which is just above Orion from our perspective here. Taurus has this characteristic Y shape, and it has the bright star Aldebaran in the top left corner. And so this is a bull that, I'll turn on the art here, this is a bull that the hunter Orion is fighting against. Alright, so now I'm going to go back to the presentation and talk about more different kinds of objects you can see in the night sky. So I mentioned the planets, so the moon, planets. Actually, now I want to talk about open clusters, which are a nice, fun, and fairly easy observing target in amateur astronomy. So what open clusters are is they're basically small clusters of young stars that have just recently formed. A good example is the Pleiades, which I have a picture of here, and I'll go back to Stellarium and show you for it in a second. So yeah, these are clusters of young stars. They usually have hundreds to maybe thousands of stars. The Pleiades is the most prominent open cluster, and you can actually see the Pleiades with your naked eye, but there's lots of these clusters in the night sky that you can find with binoculars that are great. So I'll go back to Stellarium to show you where the Pleiades is. So I just mentioned Taurus the Bull. Pleiades is very close to Taurus. It's almost directly overhead right now, actually. So if you find the bright star Aldebaran in the characteristic Y shape of Taurus, and then you go basically just up a little bit more from that, you'll find the Pleiades. The Pleiades is also known as the Seven Sisters because there's kind of 7 really bright stars within it. And yeah, when you're in a dark site, not LA, you can see this with the naked eye. You'll probably notice it out of the corner of your eye, and you'll think you're imagining something, but in fact, it really is there. It's this nice cluster. If you have a pair of binoculars, it reveals it really well. Even if you don't know it, you're probably very familiar with this open cluster of stars, because in Japan, this cluster of stars is called the Subaru, and these are the stars that are on the Subaru logo on cars. So they're actually, it's just a depiction of this open cluster of stars. Another nice open cluster to point out is down back towards Gemini. So now we're looking east, and there's a nice cluster called the Beehive cluster, which is a bit basically below Pollux and Castor. Turn on our deep sky objects. So there's tons and tons of open clusters around the night sky. These are great objects to check out. Okay. Another really interesting object to see in the night sky is globular clusters. These are basically, clusters of stars taken to the extreme. They're very, very old clusters of generally hundreds or even hundreds of thousands of stars. And so this is what one looks like. They basically form at the very beginning of our, nearly when the Milky Way was formed. So most of the stars in them are very old. And you do need generally a pair of binoculars or a telescope to see these. But when you look at them, they basically look like a compact, kind of twinkly little snowball in the night sky. And they're really good to look at. Unfortunately, in the winter in the northern hemisphere, there's not that many really good globular clusters. So there are some, but you generally need a larger telescope to really make them nice. So I'm not going to point out any tonight, but in the summer there's some really good ones, including the Great Hercules cluster, which is M13. So the virtual meteor shower is basically going on every time I show this, but again, the meteors are basically only appearing every or basically once every 30 seconds or so. And when we do a presentation like this where I'm constantly talking, it makes it seem like there's quite a bit of time between them. But when you go out, it won't seem quite as long. So it's a little unimpressive when you actually simulate it, but it's much better if you actually go out and see them. Okay, now I want to mention a type of object you can see in this night sky called a double star. These are also, another fun object you can see. So actually, most of the stars that you can see in the night sky, they form in multiple star systems. So that means there's 2 stars, 3 stars, maybe even more stars than that. And sometimes you can actually split these and see these systems on your own. So usually you need a telescope, but there are some examples of good double stars that you can see even without a telescope. This one here is called Albireo, and you can see that there's a really nice color difference between the stars. That's because the stars have different temperatures, which is why they are like this. This software is called Stellarium. There's a link in the description. When I'm talking about multiple star systems, it would be good to mention actually Castor, which is the closest star to the Geminids radiant. And the reason for that is that Castor is actually a system of 6 stars. So it just looks like one star to us, but Castor has 6 separate stars all orbiting together in one gravitational system. And so that's actually the closest, I think, sextuplet star system to us. By the way, Pollux is also a kind of notable star. Pollux is one of the brightest stars in the night sky that has a confirmed exoplanet around it. So that's an extrasolar planet. So it has a Jupiter-like planet orbiting around the star. Let me look at questions. So why do the planets appear along the ecliptic as if on a flat disk? Well, so all of the orbits of the planets, they do sort of form a disk with only slight variation, so they're all basically in the same plane. The reason for that is that our solar system formed in a... So I just saw a... Oh, there's another one. So there's 2 rapid fire, so it's kind of random. The reason that our solar system is like that is because it formed in a protoplanetary disk. And so basically there was a bunch of gas and dust orbiting in a disk. It collapses to a disk, and so all the planets formed in that disk. Going into why it forms a disk is a little bit complicated, so I'm not going to go too deep into it. What power of telescope do you need to split stars? It depends which star. So the star that I pointed out before is Albireo. It's actually in the constellation of Cygnus, the Swan, which if I go back in time to earlier in the night, was near Saturn and Jupiter. So this is Cygnus the Swan. Albireo is here. I think basically almost any telescope will be able to split this star. The Big Dipper has a nice double star system that you can actually see with just the naked eye. Unfortunately, the Big Dipper, which is to the north, is actually below the horizon at sunset tonight. Okay, so I know that I've already gone on for an hour, so thank you for those who are tuning in. I'm gonna go ahead, and keep going through this, but if you do need to leave, I understand that. So, talked about double stars. Let's talk about nebulae now. I really can't do this presentation without talking about nebulae, specifically diffuse nebulae. And of course, the most famous nebula is the Orion Nebula, which is going back to the constellation that we've been talking about this whole night. Another prominent constellation is the Lagoon Nebula. These nebulas are basically areas in space where stars are forming. There's a link in the description for Stellarium so you can download it. So let's go back and look at Orion again. So we'll go back to the southeast now. Go back later in the night. The Orion Nebula is right below Orion's belt, right here. If you can see where my cursor is. If we zoom in on that, you'll see this really, really bright nebula. This is the brightest nebula in the night sky. Again, it's another object that just basically any pair of binoculars will be able to find it. You can even see this with your naked eye if you're in a really, really dark area. This is where stars are forming. So basically, really cold clouds of gas are collapsing and forming stars. And the reason that the nebula shines so bright is because a few really, really bright stars have recently formed within the nebula, and they're pumping out an insane amount of ultraviolet radiation that is basically reflecting and energizing this gas nebula. I think most people take pictures, most amateurs will take pictures in actual visible light, so I think this is basically what it should look like in visible light. When you look at nebula with the telescope, it'll kind of just look kind of like a cloudy area, so you won't be able to pick up this color with your naked eye. Okay, so that's one kind of nebula. Another type of nebula is planetary nebula. These are a little bit misleading because they don't have anything to do with planets. The reason they're called planetary nebula is just because basically classical astronomers thought they looked like planets. What these nebula are actually the death of sun-like stars. So when a small star like our sun, it runs out of energy, it basically expels its outer layers, and it forms this nice nebula that you can see. Again, there's lots of these in the night sky, but I'm not going to show you any tonight just because they tend to be a little bit more of an advanced amateur astronomy topic. Okay. Second to last kind of objects I'll talk about, probably the most awe-inspiring objects, are galaxies. So every single galaxy that you find in the night sky, and galaxies are extremely abundant, is an unimaginably large system that has tens or hundreds of billions of stars. Our own galaxy has hundreds of billions of stars within it. When you look at them in the night sky, their light has traveled to us for millions of years. On the right here, I'm showing an image of the Andromeda galaxy as you would see it as an amateur. And what you'll see is basically this fuzzy area right here on the right. That is, in fact, the Andromeda galaxy. The light you're seeing has traveled 2.5 million years before it reaches your eyes. Believe it or not, and this is going to be very surprising to a lot of people, but M31, the Andromeda galaxy, is actually larger in the sky than the moon is. So if you were to if you could see the Andromeda Galaxy with perfect vision compared to the moon, this is what it would look like. Now, you probably find this a bit shocking because most of you have never seen the Andromeda Galaxy, and the only reason for that is just because it's so far away and so faint. But in fact, it takes up quite a large part of the sky. Going back to Stellarium, Andromeda Galaxy is very prominent tonight. I'm going to go ahead and turn off the constellation lines. Like the Pleiades, it's kind of like almost right overhead. So we'll look a little bit more southwest, kind of above Mars. Let's see. And the easiest way to find it is with the constellation Cassiopeia. So the constellation Cassiopeia, right now I'm looking to the northwest. It forms a very characteristic W shape. This is another easy thing to see in the night sky. And then the Andromeda Galaxy is just a bit over from that, right here. You can zoom in on it and see this island world, this island universe. The Andromeda Galaxy is the most distant object that you can see with your naked eye. If you're in a very dark spot, you can see this with your naked eye. But it's actually an excellent object to look at just with binoculars. And the reason that binoculars are so well suited to looking at Andromeda is because binoculars give you a really nice wide field of view. And so I've looked at Andromeda with a 21-inch telescope, and I've looked at it with, actually this is just a pair of binoculars sitting behind me. It's actually better with a pair of binoculars because it's such a wide object. The very last object I want to point out for tonight is our own Milky Way. Again, the Milky Way in our own night sky it's one of the first things that we lose when we have light pollution. So you definitely can't see the Milky Way in Los Angeles. Many people just don't even realize that you can see it at night. But it basically appears as this faint band of light across the sky. And basically, so this picture is a picture I took actually, which is why it's maybe a little, it's not the best. But you can see the Milky Way here, and actually this is light pollution from the city, and so you can kind of see how light pollution is cutting into our view of the Milky Way. So tonight, if we look for where is the Milky Way, in the winter we kind of get the diffuse part of the Milky Way. In the summer we kind of get a thicker part, but tonight the Milky Way is basically cutting from actually between Gemini and Orion. It's cutting across the sky and going through the constellation Cassiopeia that I mentioned, and then if we were to look earlier in the night, a little too early, it's going through the constellation Cygnus. So if you do happen to be able to go out to a dark sky site, you might be able to see the Andromeda or the Milky Way. And most people, even when they do see it, they don't realize they're seeing it because it kind of just looks like, oh, maybe there's some like high cloud or something. But no, you really are seeing the disk of our Milky Way. All right, and so that actually just about wraps it up for the different astronomical objects I'm going to talk about. So let me go ahead and just look at the chat a little more, see if I can answer any more questions. Okay, so there's a question about why is like the solar system in a plane, and why are galaxies in a plane? That's a really good question. To kind of give a simple explanation is that you can imagine in 3D space, all of these gas clouds that form galaxies and solar systems, they do start spherical, and when they start to collapse under gravity, there'll basically be lots of collisions between little gas particles, and those collisions make it so that basically they basically cause the collapse into a disk. And so whichever direction that most of the particles were going in originally, whatever that plane was, basically the 3D cloud will collapse into a disk like that. Alright, so thanks for sticking with me tonight. So now I'm going to just finish up. Like I said, tons of people ask about what kind of binoculars they should get, what kind of telescope they should get. So, let's say that you enjoyed this presentation, you want to learn more about the night sky, and maybe you're interested in astronomy as a hobby. So maybe you go out and enjoy the Geminids and you decide, oh, I really like doing this, I should do this more often. And you'll ask yourself, what is the first thing I should do? And I've just told you about a ton of objects that, you could use a telescope to look for. And maybe counterintuitively, I'm going to tell you that the first thing you should do is not buy a telescope. That's not to say you should never buy a telescope, but just, if you're just starting to get into amateur astronomy, I do recommend to wait before buying a telescope. And there are some good reasons to wait before you do that. The reason that you should wait, well, number one, and I think probably all of you realize this, is that telescopes have the potential to be very expensive. A good beginner telescope will start at around $200, and then if you get really crazy into astronomy, you can spend basically endless amounts of money on it. And so you really want to be sure that amateur astronomy is actually a hobby that you want to do before you buy a telescope. Another reason is that you're not that well acquainted with the sky. So maybe, you go out, you look at the Geminids, and you enjoy it, but you don't know where any objects are in the night sky. And that can cause some frustration when you first get a telescope, because of course the first thing that you want to do is just point it on an object and see something amazing. But the thing is that if you don't know where those objects are, then it might take you a while, and it can be very frustrating, and it can discourage you, which is not something that you want. So it's better to spend a little bit more time just actually sort of getting acquainted with the night sky before you go full in on a telescope. Along this same theme is that telescopes can be kind of complicated. They have a learning curve, which can also be a little frustrating. So, again, it's good to know that you want to do this before you actually get something expensive. I guess, a telescope is a good thing to buy to sort of enhance your views of the night sky, but you shouldn't sort of get one to actually start enjoying the night sky. If you don't enjoy the night sky before you have a telescope, the telescope isn't really going to make you actually enjoy it. It's also good to wait so that you have a little bit more of an idea what you actually want. So there's lots of different kinds of telescopes. They all sort of can give you something different, and so you'll have a little bit of a better idea of actually what you want. And then finally is that just binoculars are a really great place to start with amateur astronomy. So I myself have a trusty pair of astronomical binoculars. These are basically my go-to for all amateur astronomy. These are purpose-built astronomical binoculars. They have a really nice, big lenses. But really, any pair of binoculars will do. They're great for looking at things like the Andromeda, and you can put it on a tripod if you want to. It's very easy to point it just wherever you want to, so it's a fair bit easier than a telescope. They're also usually quite a bit cheaper than a telescope. So if you're considering, buying something, maybe think about binoculars first. Now, All this is not to say that you should never buy a telescope. Telescopes are great ways to enjoy the night sky. So now I will give you some tips if you are thinking about buying a telescope. I know it's the holiday season, so maybe you are thinking about getting a telescope. So I do have a few tips based on my own experience. So on the right here, I basically just have two pictures of pretty decent entry level binoculars and telescopes. So this is the pair of binoculars I have. Here's a nice a telescope for a beginner. Child or adult, a telescope like this is nice. So my tips for telescopes: number one is try to avoid any telescope that advertises its magnification. The reason for that is that magnification is not really the objective of a telescope. Rather, the objective of a telescope is to gather more light. So the reason that we can't see lots of faint objects in the night sky is because our eyes just can't gather that much light. And so a telescope helps to basically collect more light and give it to the eye. Now, when you see a telescope that advertises magnification, it kind of means that the manufacturer realizes that most people think that magnification is what you want from a telescope, and it also generally means that they're going to advertise that because maybe their optical quality is very poor and they want to kind of like brush over that. So usually when you see something that advertises magnification, that's kind of a warning sign that the optical quality of the telescope might be subpar. It's also really important to choose something that you actually want to take out, so you should find something that's easy to transport and to set up. The telescope I have on the right here fits that perfectly. So this is what's known as a tabletop Dobsonian telescope. It's a reflecting telescope. It's really easy. This is like, I don't know, maybe basically like 2 feet tall. You basically just take it out, set it up on a table, and you rotate it around and look at the night sky. It's really easy. It actually has a collapsible part of the telescope tube here, which helps with compactability. That means it's really easy to bring it out. And when you get a telescope, the last thing you want to do is have it be like so clunky that you don't actually ever bring it out, because that would be really sad. You want to choose something with a sturdy mount. A mount is almost as important as the telescope itself. The reason is simply that you don't want your telescope to shake around. So when you point it at something, you want it to stay there. You don't want it to shake around. If the telescope shakes, then it doesn't matter anything. Doesn't matter how much light it can gather. Doesn't matter how magnified it can get. If it shakes, it's not going to be a good experience. So again, a simple mount like the one you're seeing here fits that easily, but just do your research and make sure it has a very solid mount. If you're looking for a first telescope, I would tell you to avoid a computerized telescope. That's not because computerization is bad, but just because when you're learning the night sky for the first time, it's a lot better if you actually go and find the objects yourself. So a lot of computerized telescopes, like they advertise that you can set it up and type in an object and it'll send you to that object. But in reality, things like that don't actually work unless you have some astronomical knowledge and know how to set up the telescope correctly in the first place. And so, usually you're going to end up paying more for a computerized telescope, and it's not really going to help you learn more about the night sky. Final piece of advice is just to avoid sort of mass retailers for telescopes. And that's just because, mass retailers, they generally make things that they can make faster, and that generally reduces the quality of the telescope. So I don't want to recommend any specific brands. I've kind of given you some general advice. Of course, if you ever do buy a telescope, you should do as much research as possible beforehand. But here are just some suggestions. Okay, and with that, I'll basically wrap up tonight's presentation. So thank you to everyone for joining in, and thank you for staying with me a little bit later. I think we're a little like 20 minutes over an hour. So yeah, the Geminids are going on tonight. They'll still be going on for a few more days. So I hope this inspires you to go out and see them. And then of course we have the conjunction coming up of Jupiter and Saturn in a week. So hopefully you'll get out for that as well. The UCLA Planetarium that I'm streaming as part of, we are a completely student volunteer run planetarium. So we stream usually, we're doing once a month now when we don't have in-person shows due to the pandemic. Yeah, so we it's a completely volunteer basis. Our next stream will be in January sometime, so you can stay tuned on our Facebook page and website for events in 2021. And then, you know, if I said something tonight and you want to look back on it later, maybe when you're going out to look, this whole stream will be recorded and put on the YouTube channel in something like half an hour, so you can look back on it if you want to. And of course, the software that I've been using tonight, Stellarium, again, it's a free software. There's a web version if you don't want to download it. It's really great way to explore the night sky, understand how the night sky works. So I recommend checking that out. There's a link in the description for that. But yeah, thank you again for joining me tonight, and I hope you have the best of luck with your viewing.